This is Parker Richardson, and I'm doing vectors for standard 2. A jogger ran for 15 minutes at 4 miles per hour in the direction of 40 degrees south of west. Then she stopped and turned to east, and ran with a constant acceleration of 0.3 meters per second squared for 1 minute. She stopped again, turned, and ran back to the gym with a constant velocity in all. She spent 35 minutes running and jogging. What was her velocity, magnitude, and direction as she was running back to the gym? Draw a diagram to show all relevant quantities. Write the vector of the first leg of her trip as magnitude and direction. We were given the V1, which is 4 miles per hour, which is 1.78 meters per second, and T1, which is 15 minutes, and that's 900 seconds. This is the free body diagram. This is the first leg, second leg, and third leg. This is how I found the time. dt equals 35 minutes, which is 2,100 seconds. T3 is 1,140 seconds. And how to find all 3 legs. So the first leg, which is S1, equals V1 times T1. S1 equals 1,602 meters. Then to find the second leg, you do S2 equals V2, which is 0 meters per second, times T2 plus 1/2 acceleration times T squared. So S2 equals 540 meters. The third leg, we set up a triangle OAB. So OA equals S3, the third leg. OB equals S1 sine 40, which is 1,029.75 meters. AB, side AB, is S1 cosine 40, which minus S2, which turns out to be AB equals 687.20 meters. The third leg, S3, is AB squared plus OB squared with a square root over it. S3 equals 1,237.99 meters. So, in the first leg, T1 equals 900 seconds, V1 equals 1.78 meters per second, and S1 equals 1,602 meters. In the second leg, the acceleration is 0.3 meters per second squared. The time, T2, is 60 seconds, and S2 is 540 meters. T3 equals 1,140 seconds. S3 equals 1,237.9 meters, and V3 is 1.08 meters per second. So V3 equals S3 over T3, which equals 1.08 meters per second. That's the velocity V3. So the first leg, the vector of the first leg is 1,602 meters at 40 degrees south of west. The X component and the Y component. The vector of the second leg, S2, equals 540 meters at 0 degrees east. The X component is 540 meters, and the Y component is 0. In the fourth question, the X component equals 1,227.20 plus 540 meters. which equals negative 687 meters, 687.2 meters. The y component is 1,029.75 meters. The vector of our total displacement in the first two legs of a trip is S1 and S2, which is 687.20 meters per second meters squared plus 1,029.75 meters squared with a square root over it. And you get, so S1 and S2 combined, the total displacement is 1,237.99 meters. Is the total displacement of the first two legs. And the magnitude and direction is 1,237.99 meters at 33.72 degrees, 72 degrees west of south. The vector velocity as she's running back to the gym is V3 equals 1.08 meters per second at 33.72 degrees east of north.